Hi, Honors Geo students. This is Miss Brown. Today we're going to go over section 8.4, which is properties of rhombuses and rectangles and squares. So the first thing that we're going to look at is separating the difference between the definition of each of these quadrilaterals and then their properties that hold true. So the definition of a rhombus just means that all of the side lengths are congruent. So if we're looking at a rhombus, the way that we could draw it so that we know that it's a rhombus is all four sides are congruent. Okay? If you notice on this slide, it also has that it has two pairs of parallel sides, and we'll see in just a second that a rhombus is also a parallelogram. So some of the properties that hold true for a rhombus is that it is a parallelogram. So all of the properties that hold true for a parallelogram also hold true for a rhombus. So it has two pairs of opposite sides parallel, opposite angles are congruent, opposite sides are congruent, consecutive angles are supplementary, and then the one additional property that holds true for a rhombus is that the diagonals are perpendicular. So right in here, we get that. So one thing that's important to note with that, with the diagonals being perpendicular, that will be useful because we have four right triangles that the diagonals are split up into there. Okay, the next quad that we're going to look at is a rectangle. And so the definition of a rectangle is four right angles or four 90-degree angles. So again, we can draw that with our four right angles. So that is the definition of a rectangle. And then properties that hold true for a rectangle is again that it is a parallelogram. So you have two pairs of opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary. And then the next thing that's true about a rectangle is that its diagonals are congruent. So if you remember, within any parallelogram, the diagonals bisect each other. And so then within a rectangle, all four of those parts are the same because the diagonals are congruent. And so then the definition of a square is like you put a rhombus and a rectangle together. A square has four congruent sides and four right angles. So by notation, we can draw something as being a square by putting in the four right angles and the four congruent sides. So when we're looking at the properties of a square, okay, it's like all of the above. It's a parallelogram, a rectangle, and a rhombus. So all of their properties hold true. The diagonals bisect each other, the diagonals are congruent, and the diagonals are perpendicular. So if we're looking at this within our square, we've got our perpendicular diagonals. They bisect each other and they're congruent. And then obviously all of the properties of a parallelogram. Opposite sides congruent, opposite angles congruent, two pairs of parallel sides, and then the consecutive angles are supplementary. So we can kind of look at this as a flow chart, and if you look on Moodle, you'll notice that there's a flow chart posted for you. But the way that we can look at this is that all of the properties kind of flow down to the other quads. So if we start up here with a parallelogram, okay, if you notice I've got a star next to one part and then dashes next to the other. The star represents the definition of that quadrilateral, and then the dashes are all the properties that hold true. So the definition of a parallelogram is two pair of parallel sides, and then the properties that hold true for anything that is a parallelogram is opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and consecutive angles are supplementary. And so all of these properties flow down to the other quadrilaterals that are also parallelograms. So a rhombus, okay, is a parallelogram, and its definition is that all sides are congruent. Okay, the additional property that we get true is that diagonals are perpendicular. And so then same thing here, rectangle, its definition is all the angles are 90 degrees or right angles. And then the additional property is that the diagonals are congruent. But remembering that the properties from a parallelogram are true down here as well too. So a rhombus is a parallelogram, it inherits all of those properties. A rectangle is a parallelogram, it inherits all of those properties. And last but not least, we have a square. And so again, the definition of a square is that it is a parallelogram, a rhombus, and a rectangle. So it has all right angles, all sides congruent, and then all of the properties from above hold true. So all of the properties from a parallelogram, all of the properties from a rhombus, and all of the properties from a rectangle. Okay? So within this section, within your homework that you're going to work on in class tomorrow, you're going to be using and applying some of these properties. So looking at this first example, whenever we name a quadrilateral, we always want to name it by the most specific name possible. So if something is a rhombus or a rectangle or a square, we don't want to call it a parallelogram, even though it is a parallelogram. We want to call it by its most specific name. So on this example, if I'm looking at this quadrilateral, I've got 4 sides congruent. Okay, and so with 4 sides congruent and opposite angles congruent, this quadrilateral's most specific name would be a rhombus. And so again, call it by its most specific name. Even though it is a parallelogram, its most specific name would be a rhombus. And so other properties that we would know that are true about this quadrilateral, we've already got opposites, or all 4 sides congruent, we've got opposite angles congruent. We would also know that the diagonals bisect each other. The diagonals are perpendicular. Opposite sides are parallel. Okay, and then within the angles being given to us, we already have that the consecutive angles are supplementary. So ABCD is a parallelogram, and so if we know that, we can use that to find the measurement of angle A by applying a property. So if angle D is 51 degrees, and since this is a parallelogram, we know that consecutive angles are supplementary. So the measurement of angle A would have to equal 180 minus 51, or 129 degrees. So again, within your homework, you're going to be taking all of these properties that you're learning about the quads and applying them in problems. Okay, here's some examples as well that you'll see in your homework. So looking at these, deciding whether or not the statement is always sometimes true for a specific type of quadrilateral. So for this one, we're asked to look at a quad QRST. I'm just going to draw it. So here's QRST. And we know that it's a rhombus, and so we want to know, is it always or sometimes true that angle Q is congruent to angle S? And that would be always true because a rhombus is a parallelogram. Okay, the second one over here is asking whether or not QRST, which is also a parallel or a rhombus, whether or not angles Q and R are congruent. And the answer to this one would be sometimes, and that would only be true if this rhombus is a square. Okay, and so then this last one right here for any rectangle EFGH. So again, I'm just going to draw a picture here. We're trying to determine, is it always or sometimes true that FG is congruent to GH? And so this is the same idea on this one. With a rectangle, opposite sides are always congruent, but the only way in which consecutive sides would be congruent is if this rectangle is also a square. So similar to part B above, this would be sometimes, and it would be if the rectangle is also a square. All right, I hope you have a great night. We'll see you tomorrow in class.